Here are the 5 facts you must know about black holes by the end of the video. If not, I'ma throw you into a black hole.
Number 1. Black holes used to be stars.
Stars live for a very long time, but like us, they don't live forever. In a normal life of a star, there is a constant fight between the gravity pulling in and pressure pushing out. Nuclear reactions in the core of a star produces the energy pushing out. For most stars, gravity and pressure balance each other exactly, and so the star is stable. However, if the star runs out of the nuclear fuel which makes them shine, one of 3 things happen, mainly depending on its mass. The star will transform into a white dwarf, or a neutron star, or a black hole. If the star is big enough, by this I mean with a mass greater than 20 times the mass of our sun dies, it will explode into a supernova. The explosion makes the star collapse in on itself, decreasing the size dramatically. Because the size gets smaller but the mass of it does not, the gravity surrounding the star becomes so strong it absorbs everything around it, even the light. And there we have our black hole.
Number 2. They are completely invisible.
Black hole is invisible because no light can escape, so without light emissions, they are impossible to observe. Then how do we know they exist? What scientists do instead is look for the effects a black hole has on its surroundings. For example, consider a double star system in which the stars are very close. One star explodes as a supernova and creates a black hole. Gas and dust from the companion star might be pulled towards the black hole. They begin to orbit around the event horizon and then orbit the black hole.
Wait! Event horizon is so-called a point of no return. When something crosses the event horizon, it is trapped inside the black hole. This is the region where the gravity of the black hole overcomes the momentum of the material spinning around it in the accretion disk, which is the hot matter swirling near the event horizon.
Now back to what we've been talking, the gas becomes compressed and the friction among the atoms converts the kinetic energy of the gas and dust into heat, and X-rays are emitted. Using the radiation coming from the orbiting object, scientists can measure its speed and heat. From the motion and speed of the circulating matter, we can infer the presence of the black hole.
Suppose we have these 2 Smurfs. Let's call the blue Smurf blue and the glow-in-the-dark Smurf shimmer. Now our cute little Smurfs will be dancing and shimmer will be spinning around blue. But if I turn off the light, you can only see shimmer, but you can predict the existence of blue because shimmer is spinning around the central axis. Number 3. They come in all different sizes.
The mass of a black hole can range from a micro black hole with a mass as low as 22 micrograms to a supermassive black hole with a mass greater than 40 billion times that of our sun. There are 3 types of black holes depending on its size. First, the primordial black hole is tiny, ranging from the size of an atom to a mountain. Second, the stellar black hole is the most common one, which is about 20 times bigger than our sun. Last, the supermassive black hole, the humongous monster which is more than a million times heavier than the sun. And it is the one that we are most likely be orbiting right now because a supermassive black hole is in the center of our galaxy, the Milky Way.
Number 4. They are spheres, not holes.
Some people think of black holes as being circles or even funnel-shaped. The funnel shape is a misconception from people trying to explain gravity bending in space, like warping a bedsheet. The space is not 2D, it's 3D, and it's 4D if you add time. So next time when someone asks you to draw a black hole on a piece of paper, take a black marker and put a dot on the sheet. Because that's the best we can draw on a 2D plane, but certainly not a funnel shape or a circle.
Number 5. Near a black hole, things get weird.
The gravity of the black hole is so intense that time itself moves slower relative to the outside observer the nearer you get to the event horizon. And if you're ever close to a black hole, the force is so strong that your feet is pulled away from your head with hundreds of millions times the force of Earth's gravity. which means you are stretched into a long, thin strand and then shredded. And astronomers call this spaghettification. Ew.